Hello and welcome to the Eppendorf Lab channel, your home for webinars and live demos presented by life science experts at Eppendorf. I'm Simon Plate, a marketing manager for Pipettes and dispensers at Eppendorf, and we're streaming live from our headquarters in Hamburg, Germany today. Today's webinar is the first episode of our new Pipetting masterclass series, in which we cover different topics around liquid handling in the lab, from rather simple manual pipetting to automated workflows with pipetting robots. The Pipetting Masterclass features a total of 7 episodes with monthly webinars until February next year. To start off the series today, we want to share some tips and tricks on how to choose the right pipette for your research, which is also the title of today's webinar. In the next 30 to 40 minutes, you'll learn the basics of different liquid handling tool operating principles, key pipetting terminology and concepts like single and multi-channel pipettes, and which factors to consider to find the perfect pipette or dispenser for your lab. Now, I'm happy to welcome today's expert and presenter, Dr. Nadine Melius, who works as application specialist for liquid handling at Eppendorf. Nadine holds a PhD in biology with a focus on male reproductive biology from the Institute of Human Genetics in Göttingen, Germany, where she gathered a lot of experience in cell culture applications. She joined Eppendorf in 2016 and is now responsible for general liquid handling systems trainings and applicative support. Hi Nadine, great to have you here today.
Thanks, Simon, for the kind introduction, and also welcome everybody from my side.
All right, before I let Nadine start with the presentation though, I'd like to highlight the interactive features of the Eppendorf Lab channel. If you guys out there take a look to the right of your screen, you'll see a chat window which you can use to send us your comments or questions. After Nadine's presentations, we will have a short questions and answers to address selected questions. Now that this is clarified, I'd like to hand over to Nadine. The stage is yours.
Thanks, Simon. And let's get started, I would say. So I would like to start with having a look at the contents of today's presentation. So first, let's look why it's important to think carefully about the liquid handling tool which is used for a particular application. Then we will move on to look at the various options for liquid handling tools that are available. And finally, 5 questions will guide us to the right tool. And in this context, I would also like to introduce a selection chart. So let's get started. And I would like to ask, so which kind of pipette do you mainly use in the lab? And I'm relatively sure that it's a pipette similar to this one you can see here. And this is called a mechanical air cushion pipette and the most commonly used pipette in labs worldwide. But the question is, and the most important question is it also suitable for all the different applications for which it is used for? And the answer to this question is clearly no. And let's look at one example in this video. And we see, let's say, an attempt to pipette a liquid using the classic air cushion pipette. And I'm sure that we all are very familiar with this problem. The liquid is glycerol, which is a viscous liquid with a higher fluid resistance and higher density compared to water. And this causes the liquid to flow more slowly. You can see it in the video, and also creates the risk of air bubbles and drop formation. And quite often, liquid is also left behind in the tip. So liquid such as blood and also oil behave similarly. The question is, what do we often do in these cases? And when we are all honest, I think we often help ourselves with a pair of scissors. We grab it and cut off the pipette tip to enlarge the opening. And indeed, this is also often recommended on various websites. But the question is it a really good idea? And this question can also be answered quite clearly with no. Let's look at some data here on the right side. And here an air cushion pipette was used to pipette 1,000 microliter of water or 50% of glycerol. And the volume was pipetted both with an intact pipette tip and with a pipette tip that was cut 2 centimeters above the opening. And in this case, the pipette was not adapted to glycerol, and each sample was pipetted 10 times, and the systematic error was determined, which is shown here in a percentage in this graph. And just in simple words, you can say that the systematic error describes the accuracy of the device, so here from the pipette. And as expected, this error is minimal when pipetting water with the intake tip, as it should be. But we also see that cutting the tip leads to an enormous increase in the systematic error, even when pipetting water. Cutting the tip has a negative effect on the pipetting result. This just shows clearly that pipette and pipette tip should be understood as a system. But let's look at our problematic liquids, the glycerol. And here we have the pipetting results. And again, compared to the intact pipette tip, we have a huge increase in the systematic error when glycerol is pipetted with the cut pipette tip. So shortening the tip actually worsens the results, and we cut off the tip with the intention that we can pipette the desired volume better and thus more accurately, but the opposite is the case. Thus, it would even be better to leave the tip as it is. This keeps a systematic error in pipetting glycerol smaller, although it's not the best solution we have for the liquid handling tool. And not only viscous liquids like glycerol push an air cushion pipette to its limit, all liquids with physical properties different from those of water cannot be pipetted accurately with an air cushion pipette. And in addition to viscous liquids, these include liquids such as ethanol or acetone with a high vapor pressure, liquids with a different density, and also detergents. And why does the air cushion pipette reach its limits here? So for this, let's take a look at the underlying functional principles. And in general, we have two different principles, the air cushion principle and the positive displacement one. In an air cushion pipette, the piston is separated from the liquid sample by a small air cushion. And you can imagine that this air cushion works like a spring during aspiration and dispensing of the liquid. Temperature or humidity changes, as well as other physical properties of liquids, can affect the performance of such air cushion instruments. Increased vapor pressure, for example, causes the air cushion to expand. This then in turn causes substances such as ethanol or acetone to be forced out of the pipette tip, and the pipette tip starts to drip. And usually this is before we reach the target vessel, right? So the second principle is a positive displacement system. And here the piston is part of the tip and in direct contact with the liquid. There's no air cushion that may be affected by liquid sample properties. And the main reason these devices aren't the only type used in the labs around the world is actually the price. So tips or such tips with an integrated piston are more complex and thus more expensive than standard pipette tips. And due to their functional principle, the two systems I have just introduced are suitable for different types of liquids. Since an air cushion pipette is sensitive to physical changes due to its air cushion, it should be used for aqueous liquids and common buffers. For other liquids types, the pipette can be manually adjusted to the specific liquid, and you should also consider certain pipetting techniques. However, here it's very important to consider that manual adjustment makes a pipette to a fixed pipette, which then should be just exclusively used for the specific liquid type you have adjusted to. But please keep in mind that these adaptations, let's say it like this, only reduce the errors, not eliminate them. Difficult liquids should be dispensed using the positive displacement system. And the system, the dispensing tip, hermetically seals the sample. So in short, you can remember no air cushion, no problem. So now that we know that we have two operating principles, we have a wide choice of different liquid handling tools. And unfortunately, this does not make the decision easier. So before we look at 5 different questions that help us to find the right liquid handling tool for specific applications, let's take a look at our different options in the upcoming chapter. So the different liquid handling options here are arranged according to the volume range they cover. And the volume specifications refer to the currently available Eppendorf liquid handling tools. And we have already covered the air cushion pipettes, which can dispense volumes once up to 10 ml. In addition to single-channel pipettes, there are also multi-channel pipettes without and with adjustable cone spacing. They are also available in mechanical and electronical versions. And later on, we will discuss when it might be maybe beneficial to use an electronic pipette. Semi and fully automated devices, such as the EpiMotion series, also work based on the air cushion principle and can pipette volumes up to 1 ml. Mechanical and electronical multiple dispensers, on the other hand, are based on the positive displacement principle, and as the name suggests, can be used for repeated dispensing of defined volumes of up to 50 ml. These devices are also referred to as dispensers or repeaters. Especially the electronical versions usually have additional functions beyond just, let's say, normal dispensing. And the positive displacement pipette is more or less the underdog, I would say, among liquid handling tools. It is a pipette, meaning a device for one-time dispensing of a certain volume, but it works based on the positive displacement principle and is therefore also suitable for difficult liquids with other physical properties than water, because, as you remember, no air cushion, no problem. And the following devices cover a wide volume range up to 100 ml. On the one hand, we have here the mechanical and electronical pipetting aids, most commonly used in cell culture, I would say. And on the other hand, the bottle top dispensers and buettes. The bottle top dispensers can be used or easily for taking liquid volumes from storage bottles in the daily lab routine, while the buettes you can use mounted on a bottle for continuous titration. So now let's look at the decisions that need to be made in order to choose the best solutions for certain applications from this set of options we have just seen. And the question of the volume range to be transferred is also the first question of the 5 that should be answered, and in order to identify the right liquid handling tool for the application. Furthermore, it is important to look which vessel formats and liquid types are used, what is the sample throughput, and the complexity of the pipetting task. With respect to the volume, it is first sufficient to check whether the volume is smaller, let's say up to 10 ml, or larger up to 100 ml. With respect to the vessel formats, you have to clarify whether you are working with tubes, with plates, with tubes and plates, or maybe bottles. The liquid type is crucial, especially when transferring smaller volumes and due to the fact that their physical properties have an influence on the accuracy of pipetting, also for the challenging liquids. While the air cushion pipettes or principles can be used for the aqueous solutions, the positive displacement systems should be preferred for the challenging ones. The definition of whether the sample throughput is rather low or rather high is certainly very subjective, but will ultimately lead you as a user to the liquid handling tool that is right for you. Because when you think you have a high throughput, it is good to have a look what kind of liquid handling makes your life easier with these high numbers of samples you have to deal with daily. And the complexity of your pipetting task increases with the number of different volumes and or liquid types that have to be pipetted. Let's have a look at 2 application examples just to show how easy the selection chart is working. So we want to isolate DNA and perform a PCR afterwards. And now we want to determine the suitable liquid handling tools. For both applications, we have here the information on the 5 questions we have just covered. And let's look at the first part, the DNA isolation. Here on the right-hand side, we still see the information which we will now use to navigate through the selection chart. So with up to 750 microliter volume, we are clearly in the small volume range, up to 10 ml, and therefore select the selection chart for this volume range. During DNA isolation, we work exclusively with tubes, but with both aqueous and challenging liquids, such as ethanol. If you would like to consider different tools for these two liquid types, you could continue along the path here for both aqueous and challenging liquids. If one tool is preferred for both, the selection should continue here at the point with the challenging liquids. Throughput as well as complexity have been rated as low. So at this point, a mechanical multiple dispenser from Eppendorf, it's the Multipette M4, is recommended for this DNA isolation. Let's have a look at the second example. Again, we see the information about the PCR to be performed here on the right-hand side. So we are working with volumes up to 60 microliter, and accordingly, we select the selection chart for volumes up to 10 ml. In this case, we are working with both tubes and plates. We are working with challenging liquids, such as PCR master mix, which unfortunately tends to foam. But the throughput as well as the complexity is considered to be rather low. So at this point, two liquid handling tools can be considered for the PCR setup. Again, the mechanical multiple dispenser from Eppendorf, it's the Multipette M4, and an air cushion pipette with adjustable tip spacing as we switch between tubes and plates. We will come briefly to this, let's say, special form of pipette in a moment. So I hope that these two examples have shown that you can find the right liquid handling tool from the wide range of tools available by just answering 5 questions about the pipetting task you are planning to perform. So I think it's quite easy. And this selection chart I have just shown is available as a download and contains 2 charts, one for the small volumes up to 10 ml on the left-hand side, you can see it, and one for the volumes from 5 to 100 ml. Let's have a closer look at 3 points concerning the selection chart in more detail. Point 1 is when recommending air cushion pipettes, a differentiation is made between single and multi-channel pipettes. In addition, there's the already mentioned multi-channel pipette with adjustable tip spacing. But when should I use which pipette? In general, you can always use a single-channel pipette. That's not wrong. However, multi-channel pipettes can make your life in the lab much easier and save you a lot of time, and also minimize the error rate and in turn increase the reproducibility of your results. Why? Let's have a look on the next slide. If you select a multi-channel pipette according to your plate format, you can fill column by column or row by row, shown here for the 96 well and 384 well plates. Of course, if you want to challenge yourself and your concentration a bit, you can also use a 12-channel pipette instead of a 24-channel pipette to fill the row of this well plate. But I think the advantages are quite obvious. So multi-channel pipettes reduce the number of pipetting steps. So if, for example, a 24-channel electronical pipette is used instead of an 8 or 12-channel pipette, your 384 well plate is filled 5 times faster. The simultaneous filling of the wells row by row or column by column considerably reduces the risk of errors. And the work is also made easier for your hand. You can imagine, because the pipette tips are ejected successively with only one dispensing pressure, so the ejection forces are reduced. For our PCR approach, we were recommended a special form of multi-channel pipettes. For Eppendorf, it's the Move It, where you can manually adjust the cone distance, and this facilitates a format change. For example, as shown here on the right-hand side, from samples from different tubes into one plate. And here you can also look for mechanical as well as electronic versions. And this is also our next topic, our point 2. When should I use a mechanical and when an electronical device? If you take a closer look at the selection chart we provide, you will notice that the mechanical version is usually recommended for a low throughput and the electronic version for a higher throughput. But also here the comment, it's never wrong to use an electronic version. Sometimes it is, or maybe often it is also a question of budget, because the electronic versions are naturally more expensive than the mechanical ones. So let's take a look at a few factors to better evaluate whether and when the investment into an electronic device might be of value for you. So here we have some facts. So I think it's quite obvious that working with electronic liquid handling devices saves a certain amount of time. The devices usually offer various operation modes, so they can be used for more than classic pipetting, but also for dispensing, for example, multiple dispensing. Some of these devices can also be used for titration, or also the quantification of liquid residues and other quantities. So pipetting sequences for routine processes can be saved as programs, and the instruments can be adapted to specific liquid types. So this is called the temporary adjustment, and there is no need for calibration. So this makes the adjustment to challenging liquids quite easy for such an, for example, an air cushion pipette. With regard to the GXP requirements, settings and programs can be password protected, or reminders for maintenance, etc., can be set. So you don't have to worry about missing any dates for checkups and calibrations. And with regard to the experiments and collecting data, however, I would say reproducibility due to the increased precision is certainly the most important point. Let's look at the random error here of measurement using mechanical and electronic pipettes. Again, here on the right-hand side. Here we use different volume variants for pipetting, 10%, 50%, and 100% of the nominal volume, and compared the random error in percent when using the mechanical, shown here in light blue, and the electronic variant shown here in green. In short, the random error describes the imprecision caused by worn parts or incorrect handling of the device. And I do not want to go into detail about these values because I think it becomes quite clear that the random error, meaning the error that is not related to the device, but due to its operation, is smaller when using electronic versions. So as a matter of fact, better precision is usually achieved with the electronic pipettes. And what is the reason for this? It's quite easy because the electronic system specifies the defined stops, uniform piston movement, and the uniform speed. And this is something which has an impact on reproducibility of data. Last but not least, with the choice of the liquid handling tool, another decision has to be made, and this is a pipette tip, our point 3 here. It is important to consider the liquid handling tool and the tip as a system. We have seen it already at the beginning when in the video when pipetting glycerol with cut tips. And the measurement deviations specified by the manufacturer are only valid for the liquid handling tool and the corresponding tip. So a tip of poor quality can have a significant and above all negative influence on your pipetting result. Some systems, of course, already determine the corresponding tips. So it is quite obvious that pipetting aids are used with serological pipettes. Maybe here the accuracy and precision is not that important when we think about cell culture applications and media changes and stuff. The Eppendorf multipads are so-called closed system, can just be used with combi tips advanced. But there's also a large collection of different tips for air cushion pipettes on the other hand, and this can be quite confusing. So you have tips with filters, you have tips without filters, you have elongated tips, you have tips with different purity grades. And also here, to make the decision a little bit easier for you, we have also provided or developed a selection chart and this is also available. You can use, once you have identified the right liquid handling tool for your application, you can use this overview to see which tips are suitable for the liquid handling system you have determined. And in this context, you should just answer 2 questions. So is there an increased risk of contamination in the application you want to perform, and what type of liquid is used? And in this way, you can quickly and quite easily identify the suitable pipette tips for your liquid handling tool. And yeah, with this webinar, we wanted to illustrate that it makes sense to ask the question which pipette is best suited for this application. So it is not always the classical air cushion pipette that is primarily suitable for aqueous liquids and buffers. If you use it for difficult liquids, you should consider a temporary adjustment of your pipette and also certain pipetting techniques. In general, positive displacement systems are more suitable for these liquids, and in addition to the liquid type, also consider the volume to be pipetted, the vessels used, but also the throughput and the complexity of your pipetting project. And using the selection chart presented here, you can easily and quickly identify the suitable liquid handling tool and also tip. And with this, I'm at the end of our presentation. So thanks for your attention so far. And I would like to hand over to Simon again for our Q&A session.
Thanks, Nadine, for this great presentation. I think we all learned a lot. We got a few interesting questions from the audience. So basically, you mentioned it in the presentation, but can you remind us again which pipettes or which type of pipette is most accurate?
Okay, so thanks for this question. As already mentioned in the webinar, we have 2 different operating or functional principles. We have the air cushion principle for aqueous solution and the positive displacement system for challenging liquids. And in general, you can say that the highest accuracy and also reproducibility can usually be achieved with positive displacement pipettes or dispensers, especially when you're working with challenging liquids. Of course, also air cushion pipettes lead to reproducible results, but in some cases, and here it's meant with challenging liquids, you need to use certain pipetting techniques, consider the temporary adjustment. And in general, an electronic pipette or dispenser can eliminate, of course, a lot of variance from pipetting and also pipetting between different users. So, yeah.
Okay, thanks for that. I think that answers the question quite well. The second question I'd like you to answer is the question from the audience, which asks, why do pipettes drip? So you mentioned it shortly in the beginning, but they are not sure if they got it right in the audience. So maybe you can explain shortly again why pipette sometimes drip from the tip.
Yeah, of course. I try to explain once again. In general, air cushion pipettes tend to drip when you are pipetting volatile liquids. And this is due to the air cushion, which exists between the liquid sample and the piston inside the pipette. So air is flexible. It adapts to external influences such as temperature and air pressure, and thus it expands or compressed. And liquids, on the other hand, are also subjected to such external factors and naturally evaporate as the humidity of air is lower. And a volatile liquid, like, for example, ethanol, evaporates much faster than water. And during pipetting, it evaporates into the air cushion and forcing it to expand. And thus, the liquid is pressed out of the pipette tip. And then the pipette tip starts to drip. And as a rule of thumb, you can actually remember that air cushion pipettes should be used with caution when with all liquids that have physical properties different to water.
All right, thanks. We do have another question about reverse pipetting, actually. So the question is if reverse pipetting increases accuracy when working with high viscosity liquids. Can you tell us more about that from the top of your heart?
So actually for high viscosity or high viscous liquids, your first choice should be the positive displacement system as described in the webinar. However, when you are not having a positive displacement pipette or dispenser, you can use a reverse pipetting technique. You will probably increase your accuracy. However, it will not be as good as with the positive displacement device. But of course, the reverse pipetting is better than cutting the tip.
All right. Okay, we do have one additional question, which I can actually answer myself as the marketing manager, which is if electronic pipettes are UV resistant. That is actually the case for Eppendorf Explorer pipettes. So I'm not sure if every electronic pipette out there is UV resistant, but our Eppendorf pipettes are actually UV resistant. All right. As far as I can see, we have, yes, another question. So basically, there is a question regarding accuracy checks between calibrations. Do we have any recommendations how to perform, or if accuracy checks between calibrations should be performed and how to do it?
So in general, you can do a so-called dripping test. So you can use your air cushion pipe. Let's say for an air cushion pipette, you put your tip on your air cushion pipette. Let's say you have a 1,000 microliter pipette. So the nominal volume is 1,000 microliter. Take it, aspirate water, and wait 1 minute. And so you should not see after 1 minute any drop formation outside the tip and stuff like this. So then this is the first sign, let's say it like this, that fitting of tip and pipette is still good. However, for the accuracy, you have to make really measurements. So it depends on what kind of way you can weigh your the drops and stuff. So this really depends on the equipment you have, but this would be the best way to check for accuracy when you want to check it also in between different calibration checks.
Yeah, thanks for that. Maybe just as an addition, we also have a user guide regarding the topic of calibration and adjustment of your pipetting systems. Just go to the Eppendorf website and look for user guide number 25. That's user guide number 25. All right. As far as I can see, we have now answered, a lot of questions. If there are more questions posted to the chat, which I haven't seen now, we will make sure to go through that again and answer your questions also afterwards. But for now, I'd like to wrap up our round of questions and answers. Thank you, Nadine. It was a great presentation and a great discussion. Thank you for that.
Thank you, Simon, and thanks also for the attention in the audience. So thank you, and I hope we see us again in the next webinar.
All right. Before letting you guys in the audience off the hook, I just wanted to highlight again that we're doing a full series of free pipetting webinars here. The next episode will be streamed live 2 weeks from now on the 7th of September, and it's titled Proper Pipetting with Air Cushion Pipettes. Don't miss out on the tips and tricks for proper pipetting technique that we'll share then. And goodbye, and see you next time in the Eppendorf Lab channel. Thank you very much.